Hello everyone, today I'll be going through the math method 1-2 week 8 mini test. So right now the answers are just on the screen. So if you just want to check the answers, then go ahead. All right, cool. I'll start going through the questions now. So first one, it asks us to find the implied domain range. So the implied domain is to a square root function, is that the number inside the square root function must be, well, above zero or above or equal to zero, because you can't square root a negative number. Therefore, we can write 2 minus 2x is greater or equal to 0, which gives us 2 is greater than or equal to 2x. Therefore, saying that x is, well, smaller or equal to than 1. Therefore, the implied domain for this question is just negative infinity to 1 inclusive. And the range is, well, if we think about it, if x equals to 1, the square root will give us a value of 0. And therefore, the biggest value of this function that can have is 3. But if x is, well, if x gets less and less, so like closer to negative infinity, the square root will give us a bigger number. With a negative on the front, that will give us basically even bigger negative number. Therefore, the range is from negative infinity to 3. And it's the same logic for the second one. We have to make 4 minus x squared greater or equal to 0, which makes it 4 is greater or equal to x squared. Our way to kind of see this is through the graph on the right. If we graph y equals x squared, and we can kind of see at x equals negative 2 or 2, x squared is equal to 4. Therefore, if we want x squared is less than or equal to 4, then we know the domain is from negative 2 to 2 inclusive. And the tricky part of here is the range, because if we solving x equals negative 2 and 2 in this question, we will both get ranges equal to negative 3. And we can see on the graph that when, so because x gives the same value when negative 2 equals negative 2 or 2, then that's not the implied range we're looking for, because we're theoretically looking for the greatest and the smallest value that the square root sign can produce, right? So inside the square root, we have 4 minus x squared. And to have the greatest value, we must have x squared equal to 0, which will give us a square root of 4, which is 2. Then negative 3 plus 2 is negative 1. Therefore, our biggest value is negative 1. And the smallest value this will give us is when x squared is equal to 4, since because of that, the square root will equal to 0. And that's why our range is from negative 3 to negative 1. All right, question 2. We're trying to do the transformations from y equals square root of x to y equals to negative 2 times square root of 3x minus 1. And I kind of have all my steps listed down here, and the arrow kind of just shows what it did to the graph. So first we divide by a factor of 2 from the x-axis. We'll change this graph to y equals to 2 square root of x. And then we reflect in the x-axis, which becomes y equals to negative 2 square root of x. And then here is the tricky part. Remember, when we're dividing by a factor of y, it's always the reciprocal of it. So if the graph is changed from x to 3x, therefore we divide it by a factor of 1 on 3 from the y-axis. So it changed to y equals to negative 2 times a square root of 3x. And then we are translating it 1 on 3 units to the positive direction of the x-axis, aka to the right. Then we will have something below like that, because we'll get y equals to negative 2 square root of 3 bracket x minus 1 on 3, which can be expanded into negative 2 square root of 3x minus 1, which is, that's what the graph is after. So these 4 transformations are what I did. There's more than one correct answer to this, as you can do them in different directions, but as long as they work out from the original graph to the image graph, then it's all good. All right, question 3. We are given a set of transformations, and we are trying to find the image function. So what I like to do to this is that I would, instead of writing y is equal to this, I like to write it in function form. So I will write it as f of x is equal to x squared minus 3x. And first transformation is dilation factor of 3 from y-axis. And remember, as I said before, any dilation from the from the y-axis, it's reciprocal. Therefore, instead of f of x, we have f of x on 3. So we change every single x we see in f of x into x on 3, which will get x squared on 9 minus x. And there is a reflection in the x-axis. Therefore, we just add a negative to the front, and we get x minus x squared on 9. And the final part is translate 2 units left, which we know in transformation form is just writing x plus 2 in a bracket. So we will change every single x from the graph before into x plus 2 as shown, and we will have our final image function equals to x plus 2 minus x plus 2 squared on 9. And keep in mind, right now I'm writing everything in function form, but we have to do the final line here is to convert this from function form into y dash is equal to all this, because we're looking for the image function. So we can't leave it in the function form. All right, cool. So that's all the answers for this week. If you guys have any questions, feel free to ask me on WeChat or come to the Math Study Hub, which runs every Tuesday from 6:30 to 8:30. All right, see you guys next week.